an equals sine n over n for all positive integer n, prove that the limit as n approaches infinity of a of n equals 0. Okay, so we want to find the lim as n approaches infinity of sine n over n. Okay, so not to be confused with the limit as n approaches 0 of sine n over n, which would be the fundamental trigonometric limit, which would be 1. Okay, none of these sequences are on their own converge to anything. I mean, there is an argument for saying, well, sine n, the maximum it's ever going to get to is 1, and the minimum is minus 1. So if you're dividing that number by infinity, then it's going to approach 0 anyway. But for a conclusive proof, what we're going to do is try and use the squeeze theorem, right? So one thing we do know about sine n, as I've just said, so sine n, we know has a maximum value of 1 and a minimum value of minus 1. So it's bounded for all n, it's bounded between that upper and lower bound, minus 1 and 1. Okay, so we can just divide everything by n. Now we know that n is positive, so when we divide by n, it's not going to flip the inequality, right? So minus 1 over n is less than or equal to sine n over n, which is less than or equal to 1 over n for all positive integer n. So as I say, if n was less than 1, then you might have to think about flipping these inequalities. But as we know, n is not, n is always positive. This is absolutely true. So now we've got two easy limits to find, and we can lead towards the squeeze theorem, right? So the lim as n approaches infinity of minus 1 over n less than or equal to the lim as n approaches infinity of sine n over n, which is less than or equal to the lim as n approaches infinity of 1 over n. Okay, so these two are really, really simple limits. We find them all the time. 0, 0, so this must be 0. But as we're actually doing a sort of proof, I'll just write that down. So the lim as n approaches infinity of minus 1 over n equals minus 1 times the lim as n approaches infinity of 1 over n, which we know equals 0. You can accept that that's the standard result. So the lim as n approaches infinity of 1 over n, well, we know it's 0 anyway. Therefore, we've got a 0, which is less than or equal to the lim as n approaches infinity of sine n over n, which is less than or equal to 0. So that tells us conclusively that the lim as n approaches infinity of sine n over n equals 0, and the reason is the squeeze theorem. You should say what you were doing. Squeeze theorem.